Welcome to our Maritime Innovations interview series. Today we are cutting through the marketing noise surrounding wind-assisted propulsion. We want to understand the engineering reality versus the green promise. And today I have a special guest, and it's Aldo Cattano. He's a founder and CEO of Windtracx. Aldo, very welcome to the show.
Welcome to you. Thank you very much for this possibility of showing my project. And I'm here and happy to answer your question.
Good. Aldo, moving from aerospace engineering to maritime innovation, what key learnings did you take from earlier wind-assisted concepts, and what specific problem is your current system solving?
So starting from aerospace, I love airplane. I was starting building airplanes. Then I was moving to wind turbines. Then I developed a lot of mini wind turbines. And then at a certain time, I found that there was a wind turbine that was a plane and a wind turbine. And that was airborne wind energy. There I was developing a startup called Skypool. It was going really well. We were reaching tier 7. So we had a prototype. We were producing electricity. We were making a lot of flight tests. But the market was a bit saturated, so they were not feeding tariffs anymore. And at the end, I had to leave the project. I didn't have any finance to move on. And then I saw this year beginning that there was this new regulation from the European Commission that oblige more or less ship owners to do something to help the world to decarbonize. So, and I love that. In between, I was working for a really big company for decarbonization, that is Climeworks, and I said that I have to go back and try to help the world again. And sure, from aerospace, I have a lot of design way of doing things. So mainly in aerospace, you always have to be fail-safe. So what does it mean? When you fly in your airplane, commercial one, the airplane has a lot of things that are broken, and you don't know it. But it's meant to be that even if there are some parts broken, there are some other that can make the same. And the same I'm doing here. So this kite, drone, how you want to call it, has a lot of propellers, motor. Even if you break one, the others are working. We have a lot of control surfaces. And so that the important is reliability and safety. So, and this is something that I think that why we are so interesting in the looking at kites. So at the moment, kites are there. They have only one control system. It's a passive system. So if you take off or landing, there is a problem with wind. The kite can go and splash into the water, and then it's quite difficult for a so big kite to take it back. We have a system that is completely autonomous, fail-safe, safety first, and also we can really fly in almost all possibility of wind. So maximum we are going to Beaufort 8.
With that background in mind, let's look at the specific engineering behind your solution. You've developed a tethered glider kite drone approach. Can you explain how this system works without using marketing language and technicality, but how does it differentiate from previous kite-based systems?
We were at the beginning in the airborne wind energy sector, and there were a lot of kites. So soft kite is a passive system. There is always a problem for takeoff and landing because you never know really how to do that. In fact, the actual kites are anyway have a second rope, mainly only for takeoff and landing. In our case, we have propellers, so we have rigid wing. Why that is different and what is better or worse? For sure, we are a bit heavier, but as we are an active system, we have always our propellers. So we decide to take off even at 300 meters. There is a lot of wind, but perhaps at the sea surface, there is no wind. Who cares? We can anyway take off. If then perhaps when you want to land again, there is no wind. And perhaps the direction of the ship is not the correct direction for getting wind, we can still have no problem. So we are an active system and also with a lot of redundancy. So also another thing is that, okay, think of a kite. A kite profile is a soft profile. So the lift coefficient is not so high, it's more or less maximum 1. In our case, we have a lift coefficient of 3.1 that we were testing already inside the wind tunnel test of ATH, so Polytechnic of Zurich. And but anyway, in average, I can say 2.5. Now, okay, we have less CL than a rotor or than a suction wing. But there is another thing really important, the apparent wind. So if you think at America's Cup, if there are 10 knots of wind speed, then the ship are flying at 50 knots, 5 times more than the wind. And this is why, because more wind you do yourself, and more wind you feel, and more lift there is, because the lift is based on the apparent speed. So that means it on a normal ship, so for example, a rotor that is based on the deck of a ship, you have to take in account the wind speed and the ship speed, and you have to make a vector of the two. In our case, we are making an APAF really fast. So what is that? We have an apparent wind that is much higher, and the lift is proportional to the square of the speed. So that's why it's much better. So we need not a really big surface. The CL is much higher. So and also the last thing is that we are at 300 meters height. At 300 meter height, there is much less turbulence. The wind is much more constant, and there is a bit more wind. Something like 40% more wind than at the sea level.
That's very interesting. And moving now from the concept to the deck of a working vessel, for fleet managers watching now, what are the suitable vessel types and trade routes for such a system, and how does it behave in challenging conditions like heavy weather or congested waters?
So a fleet mainly we love to work with bulk carriers and with tankers. Also chemical, mainly not that much, for sure not with passenger, because a drone is always something that could be dangerous, and not mainly with container ship, because anyway, our storage, so if the weather is too bad or there is no wind, anyway, the drone has to be stored. Now, a soft kite, the stored place is really a box, a square box. In our case, we have folding wings so that our space is not so big. We anyway will be in the front of the ship, but anyway, we will take a bit of space. For that, container ship is not the best. Now, congested area, Laura, as we are coming from I can say, airplane sector, we already think about if an helicopter is approaching, if an airplane is approaching, also if another ship is approaching. In that case, autonomously, the drone will land. And it will not take 50 minutes as a soft kite, but in 2 minutes, we already landed safely and with no problem. Now, wind, for sure, as also the kite surf, they cannot really fly headwind. So perhaps we will take a bit less headwind than a rotor sail or suction wind, but a bit more than a soft kite. But looking at the if we have the wind from the back, in this case, the other system are working like not anymore taking in advantage the lift, but the drag. So it's like that you have a Roman sail that you have only can work with the same maximum, the same speed of the wind. In our case, anyway, we make always the 8 path, so our speed is much higher. So we are still working with the lift, so we can get much more lift on wind coming from the back.
Yeah, and that's also very interesting to learn. And also what I didn't know, that you can land so fast. And speaking of challenging conditions, we have to talk a little bit about risk management. So from an engineering standpoint, what are the critical failure scenarios you have modeled, and what are the operational safety considerations if things don't go too well?
The most challenging thing is always takeoff and landing, and that we already know from the soft kite. For that reason, we were really working a lot on how to take off and land our drone, because we have to think about the waves, that there is the front that goes up and down, also can be splashing, because we can also think about that we are landing, that the weather is too bad and we have to land. Secondly, there will be also that the ship will go left and right, and also the wind. Then wind can go also from down up and a lot of different things, because when there is a lot of turbulence and near the ship, it's really bad. So in that case, we were considering an active system that is. So we have to think that our drone is not only connected directly to a rope, but there are some bridles. So first we go to connect our brace to the bridles, and then little by little we get connected to the drone. So that the drone will touch the ground only when it's really fixed on this arm that is prevent him to destroy itself. So this is, I think, one of the most challenging. A second thing is that we break the tether. And in this case, it's a bit more simple than on a soft kite, because we have a much higher passive safety and active safety, because we have an active system. We will put the tether safety factor a bit lower, so that we can use also a smaller rope. And that means that we can put the drone a bit higher or more far away. In this case, we can break the tether. And if we break the tether, okay, we will land anyway on the ship, if anyway the weather is not so bad as in.
And does it require any personnel, any staff that, or is the full process automatic?
So we have to do like that. So nobody has, apart the captain, or the officer that has to push the button. Okay, you can start. Then the drone will understand if we are already far away from the shore, if there are no ships or helicopter, whatever on it. Then it will start understanding the wind direction and the ship direction. Then it will check on board if the ground station is working, if the drone is working. And then after that, only it will start. For sure, the fleet, the crew has to make a course, mainly for safety reasons. So what we want is that they have not to be near there. They have to be, they know all the risk of safety about the drone. So, but nobody has to touch anything. And we also, if there is an emergency, or if one of the 8 motors break, there will be an emergency procedure. It will land, and only in the next harbor, somebody of our company will go there and make the maintenance. And we, in fact, we want to sell the system and also to sell yearly maintenance to be sure that everything is work finally.
Right. I mean, that sounds very good. And safety is a prerequisite, of course, but the economics ultimately drive the decision. And under conservative assumptions, what are the realistic fuel saving ranges ship owners can expect, and how does this expected ROI logic align with current regulatory pressures like the EU ETS?
I was a space engineer. I was certifying airplanes before. Then I was certifying wind turbine. Then I was certifying also the drone to fly as a plane. So also that was really difficult certification to get, because you have to think that you have also to land where people are there. Now, in this case, it's a bit less strict, because we have only to think about that we have to certify that our system is able, that the structure of the ship is able to withstand our drone, that there are no problem if the drone will land on the ship. So that for sure we have, in fact, is one of the first things that we have to do now when we start to think about the pilot program. And another thing is that what we did said, okay, we go to a company that has a certified software, and that was Blue Wasp Marine, based in Rotterdam, and they certify for a certain ship, a certain group, and a certain wind assisted ship system, how much decrease of consumption you have. So there was a company, a middle company of tankers, European, that were asking us that. So we went to this company, said, okay, can you make documentation about that? So we have to pay for a report. And in the end, it was a 50,000 DWT ship, LR1 tanker. And on 5 different routes, we had an average of 5% of decrease of consumption. And maximum was 10%, minimum was 2.5, because it was passing through the equator. So for sure, North Atlantic is the best place, always windy place. And also it was not taking really care about the 300 meters height of wind average, because these data are not really yet available on the market.
So, Aldo, I think a system like yours has a lot of other potential as well, especially for scaling. What do you have in mind here?
But for sure, as all our competitors, we have to start with a small scale, but then we are not able really to pull a really big ship. So what can we do? And we're thinking, okay, we are flying at 300 meters. How that can work? Because until there is wind, we always stay there without any electricity. So if we add a little small weather station, then we can increase the weather forecast locally to a lot of higher precision, also for routing. So again, to decrease fuel consumption, also if there is really bad weather, to understand if really we can pass there or it's better to go back. So it's like improving the weather forecast. We are already talking to some weather forecast companies and they are interested. Secondly, we are at 300 meters. If the weather is good, we can also already see things at 20 kilometers away. So we can use it with webcams and other sensor as a surveillance. So for sure, if we are in a pirates zone, we can check if the pirates arrive and also if the drone of the pirates arrive. And if on the ship there is an anti-drone cannon, then we can tell the drone automatically where to shoot.
Oh, the fascinating additional possibilities that come with this product. So, finally, let's place this technology on a realistic timeline. What is the current technology readiness level, so the TRL of Windtracx, and where do you realistically see this technology fitting into the market in the next 5 years?
Thank you for the question. So we were already reaching TRL 7, but we were on the ground. Now we have to, a bit refit the system because it has to live for a lot of time in the salt. So we have to think about a bit redesigning a lot. And for this case, we can say that now we are at between 5 and 6. And but we have already all the prototypes. So now we will start with testing it in the lake nearby, because we are in the south of Switzerland. There is windy lake. And so we are thinking about this year we are developing mainly on the ground and testing on the lake. Next year we would like to certify our scaled model with the certification body to be ready for a pilot project in the third year, where we already will hope to start selling our system, even if at small scale.
Thank you very much. I wish you best of luck for that. And thank you for defining the current status and the engineering reality behind Windtracx. For our audience, this was an editorial deep dive into wind-assisted propulsion. Aldo, thank you so much for your time today.
Thank you to you. Have a nice day.